Good evening, everyone, and welcome to our live coverage of the latest mission from NASA's Kennedy Space Center. I'm Will Robinson-Smith. I'll be providing our commentary for the duration of this coverage. We're broadcasting, as we always do, from the Spaceflight Now News Bureau here at KSC. And a good evening to all of you as Intuitive Machines, SpaceX, and NASA are preparing to embark on what is set to be the fourth flight supporting NASA's Commercial Lunar Payload Services, or CLPS program. This is an undertaking that endeavors to bring NASA science and technology demonstrations to the surface of the moon at a lower cost than if NASA were to go it alone and develop the technology for both the tech demos and the science experiments as well as the lander itself. This time around, NASA is the customer, and Intuitive Machines, based in Houston, Texas, is in the driver's seat. Intuitive Machines is responsible for the Nova C lander, which is currently encapsulated in the Falcon 9 payload fairings at the top of the rocket stack, as well as procuring the launch that we're about to see in T-minus 1 hour, 57 minutes, and 26 seconds, which will be provided, of course, by SpaceX using its Falcon 9 rocket. The mission, called IM-2, targeting a liftoff from Pad 39A here at the Kennedy Space Center, coming up at 7:16 p.m. Eastern, 0016 UTC, for our friends joining around the world. And to those near and far who are with us at the start of our broadcast, want to wish you a warm welcome in. Hope your week is going well. See, we have about 1,400 of you watching with us live at this point in our broadcast. If you haven't already, you could do us a big favor just by clicking the like button, sharing the stream, allows more folks to find their way into this live launch coverage as we roll on towards the liftoff of this Falcon 9 rocket. As we're getting going, want to thank our team that's in place. First off, those who are helping us out here on the live stream on YouTube, our moderators holding it down in the live chat. Appreciate you to Jeff Hansen, Callistia Lee, and Rick Donner. We'll keep an eye out for any of the other moderators who happen to cruise on in as we continue on with the countdown today. But you could help them out with their moderation duties just by following a few simple things. If you could, of course, refrain from going into overt politics. This is not the venue for that, respectfully. We'd also ask that you, when you use the live chat, communicate in English so that our moderators can fully understand the conversations that are going on and respond appropriately. We also ask that you refrain from using all caps and, of course, the golden rule. Treat others as you would like to be treated. Every launch could be someone's first, and so if you see a question in the live chat that you know the answer to, show them the same grace that you would like to have been shown on your first launch. Got our launch crew out here helping us out today as well. Our Spaceflight Now editor, Stephen Young, is running the technical operations of the broadcast. Photographer Michael King getting ready to do some still photography with this mission. He was out and about setting up some remote cameras around Launch Complex 39A, getting ready to take some photos remotely of the Falcon 9 once it makes its ascent from the launch pad. Adam Bernstein is off, but we are joined with tracking assistance for today's Falcon 9 launch by our friend Pete Carsons with Max Q Productions, as well as Chuck and Jen Briggs with C&J Images. If you're not following us on our social channels, you can find us by simply looking for Spaceflight Now on X, Threads, Blue Sky, and Facebook. This is the mission patch for today's Falcon 9 launch, supporting not only the Nova C lander, which you can see a graphic of within this mission patch. Just to the left of that, you can see the micro Nova C lander. That is the hopper called Grace. We'll talk much more about Grace as we continue on through the countdown, but it'll be deployed from the Nova C lander a little bit after it touches down on the moon. If all goes well, that'll happen next week, no earlier than March 6th. Also hitching a ride on board this Falcon 9 rocket are 3 rideshare payloads. One which is from NASA's Jet Propulsion Laboratory, that is the Lunar Trailblazer. You also have an asteroid mission that is from AstroForge. We're going to be doing a flyby of what is believed to be an M-class metal asteroid. And you also have one more spacecraft on board that is from Epic Aerospace going to geostationary orbit. We'll talk all about all the payloads on board as we roll on through this countdown tonight. We're coming on air a little bit earlier than we typically do with the Falcon 9 rocket launch. The reason being, it's not only the Falcon 9 that needs to fuel today, but also the Nova C lander that is the main payload flying. The fueling process for the Nova C, nicknamed Athena, or Attie for short, starts about 3 hours prior to the liftoff of the Falcon 9 rocket. It's fueled with a combination of liquid methane and liquid oxygen, and because of that, they need to fuel as close to launch as is reasonably possible. SpaceX designed this late fueling process in preparation for the first time that they flew an Intuitive Machines Nova C lander. That was IM-1, which launched back in February of last year, just about a year ago. A little bit more than a year ago. Taking a look now at a rendering of the spacecraft in question. This is the Nova C lander. It stands about 4.7 meters or about 15.5 feet tall, which Intuitive Machines says is akin to a small adult-sized giraffe for those of you that are fans of visiting your local zoo. It's got a hull diameter of about 1.6 meters or roughly 5.2 feet. This Athena lander is just slightly taller than its predecessor, Odysseus. Of course, we'll have much more on the lander itself as we continue on through the countdown tonight. Currently T-minus 1 hour, 50 minutes, 50 seconds and counting. About an hour and 12 minutes away from the point at which the SpaceX launch director makes the call on the start of prop load for the Falcon 9 itself. Again, fueling on the Nova C lander should be underway as we speak. As always, we appreciate those of you who are supporting us with channel membership. It's what helps sustain these live launch broadcasts and allow us to do on-the-ground reporting as we've done in the run-up to this mission. You'll be hearing some of the fruits of that as we roll on through the countdown from the various folks involved with all the payloads and science instruments on board. From the lander itself to the Lunar Trailblazer, which was built by Lockheed Martin Space. Also hear a little bit from the CEO of AstroForge about their second asteroid mission. Want to welcome in some new channel members as we're rolling on through the start of the countdown here. A welcome to Linda Adams, Skate Letter, and apologies if I mispronounced this, Lanzamientos Especiales, all joining with channel membership at the pad leader level. Glad to have you with us. Welcome aboard. Also want to thank our moderators for some generosity here. Jeff Hansen gifting 5 Spacefly Now memberships, and Callisti Lee for gifting 10. Thanks to the two of you for helping us out with moderator duties and for growing our community here on YouTube. And to our newest 15 channel members, welcome aboard to you all. Glad to have you with us. And if you haven't already, be sure to thank Jeff and Callisti in the live chat. And we hope you decide to stick around with channel membership beyond the month you were just gifted. Last for now, want to thank Bro for a very generous $20 super chat. Thanks for your support and for the kind words. T-minus 1 hour, 47 minutes, 57 seconds and counting. Now, even though NASA is a customer on this mission, and this is not officially a NASA mission, because they are on board and they do have 2 key payloads that are hitching a ride on the lander, we should be getting mission audio loops of the countdown as we continue on with this process. As soon as those become available, we'll bring in that element into our broadcast. Once we are able to loop in mission audio, you may hear me pause periodically as I'm attempting to not step over those callouts as they happen. SpaceX is running the countdown for this mission from its facilities at the Hangar X site here at the Kennedy Space Center. It's where they refurbish Falcon boosters and prepare them for future flights, as is the case with the one flying today. Of course, Intuitive Machines is also alongside SpaceX inside Hangar X. The company also has support for this launch in part from the control room at their facilities in Hawthorne, California. And of course, Intuitive Machines is going to be picking things up from its facilities over in Houston, Texas. So very much a cross-country effort to bring this all together. And of course, you've got the teams with Epic Aerospace and AstroForge, which are also monitoring the health of their spacecraft, as is NASA with the Lunar Trailblazer. Coming into tonight's launch opportunity, a fairly good outlook from the 45th Weather Squadron, which is based at Patrick Space Force Base. I want to take a look at this camera angle here before we dive too far into the weather, partly because it gives you a really beautiful look at the sky and the fact that there are basically no clouds hanging around. And that's what I wanted to hit on with the weather, is that the 45th Weather Squadron forecast a greater than 95% chance of favorable weather for liftoff today. No concerns or constraints. The booster recovery weather is rated as a low risk, the lowest possible. And light liftoff winds trending between 7 and 12 miles per hour. That was the forecast issued 24 hours ago, and that was affirmed just within the last couple of hours by a launch weather officer during the readiness briefing teleconference. If for whatever reason SpaceX needs to pivot to its backup launch opportunity, which is set for tomorrow, Thursday, February 27th at 7:10 p.m. Eastern, 0010 UTC, weather does depreciate a little bit, drops down to about 80% favorable conditions in that backup situation, with thick clouds and cumulus clouds being watch items for liftoff. So hopefully all goes well with the launch today, which will be flying in an easterly trajectory, broadly speaking. We'll have our regular trajectory map up here in just a little bit. We'll hit it once this hour, once next hour, as folks cruise on into the live coverage. That venting you're seeing right now is part of the process of fueling the Nova C lander. As I mentioned, they start with the liquid methane on the lander and then pivot to loading the oxidizer, liquid oxygen. As we're T-minus 1 hour, 44 minutes, 5 seconds and counting, we are roughly an hour and 10 minutes away from the point at which the Falcon 9 itself will start fueling, assuming that the SpaceX launch director gives the green light to proceed with tanking the Falcon 9 rocket itself. Now T-minus 1 hour, 43 minutes, 6 seconds and counting. Taking a look from our friend Pete Carson's tracking camera view, looking at the strong back there, as you can see that venting related to the loading of liquid oxygen that I just mentioned for the Nova C lander Athena. Yesterday evening, Intuitive Machines and SpaceX conducted a joint Falcon 9 and Athena tanking test known as a wet dress rehearsal. They reported that that went well and that there were no issues found on the Nova C lander. Things progressed as expected with fueling the lander part of this. So with that assurance, hopefully things are going as smoothly internally as they appear to be from the outside. Now T-minus 1 hour, 36 minutes, 36 seconds and counting. Let's go ahead and talk about the trajectory for this mission I alluded to briefly. Once the Falcon 9 rocket takes off from Launch Complex 39A here at the Kennedy Space Center, it will be flying in an easterly trajectory heading away from Florida's Space Coast. Unlike the first time that SpaceX launched an overseas lander for Intuitive Machines, this does have a couple extra passengers, and so they were also going to be targeting not an RTLS or return to landing site landing, but rather a touchdown on the drone ship, a short fall of gravitas positioned out in the Atlantic Ocean. If successful, this will be the 100th booster landing for that particular drone ship and the 413th booster landing to date. First stage booster flying today's mission is B-1083. It's flying for a 9th time with today's Falcon 9 launch. Its previous missions included the likes of NASA's Crew 8, the private astronaut mission Polaris Dawn, SpaceX's 31st commercial resupply services or cargo flight to the International Space Station, batch of geostationary satellites for Astronus, and 4 previous Starlink missions, all before today. SpaceX is working to certify its first stage boosters for up to 40 flights apiece. Current launch leader for SpaceX still B-1067, which has flown a total of 26 times. SpaceX is also working to certify its payload fairings for as many flights. And so they will endeavor to recover these fairing halves once they splash down in the waters of the Atlantic Ocean, a little bit further downrange from where they land on the drone ship. Or from where the booster lands on the drone ship, I should say. They'll be brought aboard one of these recovery vessels, brought back through Port Canaveral, and then brought over to the Hangar X site where they will be refurbished and turned around for future flights. T-minus 1 hour, 33 minutes, 24 seconds and counting. In addition to seeing a good launch of this Falcon 9 rocket supporting the IM-2 mission, NASA is also eager to see this pad vacated because it's needed for another important mission coming up. That is, of course, the launch of these 4 folks. These are the quartet that make up the Crew 10 mission that will be heading up to the International Space Station with a launch nowhere earlier than March 12th. This Falcon 9 targeting liftoff from the pad you see there on the live shot on the right-hand side of your screen coming up at 7:48 p.m. Eastern Daylight Time, assuming a good launch today of the IM-2 mission and the pad clears and they're able to turn it around in time as expected. Time now, T-minus 1 hour, 29 minutes, 53 seconds and counting. Taking a look at our live chat, want to first off thank the 2,800 of you that are joining with us at this point in the countdown. If you haven't already, you could do us a big favor just by clicking the like button, allowing some more folks to find their way into this live launch coverage. Also want to thank channel member Chuck Close for a very generous $25 super chat. Appreciate you, Chuck. Good to see you again this evening. Also want to thank James Ames for joining us with channel membership at the Mission Specialist level. Welcome aboard, James. We're glad to have you with us. And a tip of the cap to Josh King, who's been a channel member with us for now 28 months. Appreciate your support. Today's planned launch of the IM-2 mission will be the fourth as part of, as we mentioned at the top of the broadcast, a NASA initiative called the Commercial Lunar Payload Services Program, also known as CLPS. It is that cheaper method of getting science and technology demonstrations down to the surface of the moon at a fraction of the cost for NASA, all helping to weave into the larger Artemis program, an undertaking to return humans to the moon in a sustained way and take some of that learning and apply it to eventually sending humans to Mars. I want to take a brief look back in time at the CLPS missions past and present before we see the fourth one join them. First up was Astrobotic's Peregrine lander, which you can see there on the far left side of the screen. Before it was encapsulated inside payload fairings for a United Launch Alliance Vulcan rocket. It lifted off on January 8th, 2024. Unfortunately, though, it encountered an issue with its propulsion system, and it had to return back to Earth, where it burned up in the atmosphere over the South Pacific, and it was unable to make an attempt to land on the moon. Its mission was followed a little more than a month later by Intuitive Machines' first launch of one of its Nova C landers. It was successful in touching down on the moon's surface, becoming the first spacecraft from the U.S. to return to the surface of the moon since Apollo 17 in 1972. Tiny bit of an asterisk on that, though, as part of its landing gear broke during its descent, and it ended up on its side at a 30-degree angle, which did make communications with the lander somewhat difficult. And of course, just last month, Firefly Aerospace, based in Texas, launched its first Blue Ghost lunar lander on another Falcon 9 rocket. Currently, it's in orbit around the moon and is targeting a landing coming up this Sunday, March 2nd at 3:45 a.m. Eastern, 8:45 UTC. Actually, they did just earlier today refine that landing time. They're targeting touchdown no earlier than 2:34 a.m. Central. That is 3:34 a.m. Eastern. But so far, that mission has been going very smoothly for the folks at Firefly. And of course, if all goes well with the IM-2 Nova C lander, it won't be too far behind, targeting a touchdown on the moon's surface coming up here on March 6th. Time now T-minus 1 hour, 23 minutes, 50 seconds, and counting. Ahead of the launch, we had the opportunity to sit down with Intuitive Machines CEO Steve Altemus, former NASA employee. We asked him how he's thinking about the burgeoning cislunar economy and also how his company happens to fit into that ecosystem. With the first launch that they've already accomplished and with this one coming up here, here's part of our conversation with Steve Altemus.
Yeah, I think this mission is all about, we land this mission successfully. Lunar economy is open for business, to quote Eric Berger from Ars Technica. He said that about us, right? Because what we're able to do is this regular cadence of missions. We came back a year from the first mission and said, here we are again with another lander with a much more complex set of payloads. And every time we fly regular cadence of missions, we're opening up the aperture of learning about how to live, work, and fly in space, right? We're testing engineered systems that we're going to need in the future. And so this is the first time in history ever that there's 3 lunar landers in space at the same time, potentially tomorrow, right? That's incredible. It's never happened before. So we are seeing the beginnings of the lunar economy take shape, which we've been saying at Intuitive Machines for some time, that we're setting up a commercial lunar economy. So you see us working on this regular cadence of missions, moving to heavier and heavier cargo for a logistics supply chain to be able to take things to the moon, to set up the data relay services for lunar data services around the moon, all the communications around the moon, the navigation scheme around the moon, the ground stations that communicate to and from the moon, putting that in an integrated network. So we have essentially a Verizon type network where you can sell that service to anyone who wants to go to the moon. Now, if you relieve that burden from a private company or public company, either way, a company that wants to fly something to the moon, they don't have to put in all that infrastructure to fly. They can just take advantage of what we've already built. The transportation leg, delivery, the data transmission leg, right? And operations as a service on the surface of the moon. Now we can test all sorts of ideas and engineered systems about how to harvest minerals or rare materials on the moon, how to cache them, how to build landing pads, how to do landing site selection, path planning. All those things are now things that we provide as a service that enable opening up of this economy. So I'm very excited about the future. I think having multiple shots on goal with multiple successes is good for the industry. It's good for the United States. It's good for the world.
And our thanks again to Steve Altemus, CEO of Intuitive Machines. Time now T-minus 1 hour, 19 minutes, 4 seconds, and counting. Also ahead of this launch attempt, we had an opportunity to speak with NASA's Joel Kearns. He's the Deputy Associate Administrator for Exploration within NASA's Science Mission Directorate. In the part of our conversation which you're about to hear, he gives a general overview of not only the two science instruments that are on board the Nova Sea lander that's about to launch, but also a little bit about one of the rideshare spacecraft that will head into lunar orbit called the Lunar Trailblazer. So again, this is part of our conversation with Joel Kearns.
This is a really sophisticated mission compared to Intuitive Machines 1. Intuitive Machines 1, we in effect, it was a test flight we contracted them to do, and we gave them a list of scientific instruments we had, and we said, pick which ones you'd like to put on your lander, right? So these were copies of instruments that we'd already produced at NASA. Worthwhile to get measurements at the moon, but we already had them, right? This mission is got really new customized equipment on it. It's got this this payload to look for volatiles, chemicals that might turn from solid to gas, say, on the moon, called Prime 1. It's got a drill that'll drill more than 3 feet below the surface, so we can take measurements not just at the surface, but underneath the surface. It's got what's called a mass spectrometer, which is a chemical sniffer that will look for, well, are there hidden gases or things or solids that we're going to drill through in the moon that are going to release gases, and that could give us insight into a couple of different things. At the South Pole, we believe there are some areas where there might be frozen solid water hidden in these really dark regions of the moon. But right now, we have never flown equipment to the moon to drill into that and to actually test it to see if you can robotically prove it's there. So this will be the first chance to at least test the equipment doing that at the South Pole. The South Pole is a kind of rugged area. There's very hilly terrain. There's areas that are light more often than they're dark. There's areas that are dark more often than they're light. Sometimes they're dark the whole year. So it's a really, really different area to go to. So that by itself would have been amazing for IM-2. But in addition to that, once we set that up in place, and we added our laser retroreflector that we use as like a fiduciary marker, right, for ships that fly over the moon, so they know where the ship is on the surface. That's when other industry worked with NASA, like Nokia, and said, well, they wanted to do demonstrations of how Wi-Fi communication would work and cell phone communication would work on the moon. To do that, they got a commercial rover from Lunar Outpost. So they have receivers on the lander and the rover. Then Intuitive Machines got a different cooperative agreement with NASA that said they want to build a rocket-propelled drone that they call the Hopper. Well, if you're going to have a hopper that hops around, you're going to put scientific instruments on it. So now they have a temperature probe, and they have a different type of spectrometer, a hydrogen sniffer. So now you have all these different things going on in this mission. And in addition to that, since it was going to the moon, Intuitive Machines had bought, in effect, the entire boost capability of the Falcon 9 that's going to take them to the moon. So then they were able to sell that to other players that want to send satellites out of Earth orbit, and one of them NASA decided to do. We were building a satellite out of Caltech called Lunar Trailblazer to do an orbital survey of hydrogen and oxygen and water around the moon. And since IM-2 is going to the moon, it turned out to be a natural fit for us to put Lunar Trailblazer also on it. And there's two others. I think one is an asteroid mission, and the third one I'm not that familiar with. But this has turned into a really sophisticated mission for Intuitive Machines' second attempt to go land at the moon.
And our thanks again to NASA's Joel Kearns. Currently now T-minus 1 hour, 14 minutes, 55 seconds away from the planned launch of the IM-2 mission. Now currently T-minus 1 hour, 9 minutes, 33 seconds and counting. We're roughly half an hour away from the point at which the SpaceX launch director is nominally set to make the call on the start of fueling the Falcon 9 rocket today. SpaceX does its poll electronically, so if it feels like it's in a good position to do so, they can move a little bit ahead of that. But nominally speaking, it's at the T-minus 38-minute mark when the call on prop load for the Falcon 9 rocket takes place. As we mentioned earlier in the broadcast, this will be the second time that Intuitive Machines will attempt to land on the moon. In our conversation with Steve Altimus, he says that within a month of the mission's conclusion, they conducted what he called a hot wash. Now, during his time at NASA, he served as a space shuttle test director here at the Kennedy Space Center, and said after every mission or simulation, they would go through that hot wash, which is what he described as a thorough briefing where they would, quote, take all the please and thank you out of it and take a very critical look at yourself and the team, end quote. The goal, he described, was to really get a good sense of what went right, what went wrong, and how to make it better for the next go-around. And so in this part of our conversation, Steve Altimus talks about some of the things that they were able to take away from their first IM-1 mission, apply that to IM-2, and some of the learning that happened on the fly, both literally and figuratively.
We would fly Odysseus, the first lander, again. It was a fantastic spacecraft. So if we had to repeat the mission, we could. We did put in some rigor into the software review and QC to make sure we understood all the behaviors and interactions with the software between the boxes, the controllers, etc., and the applications, and how to manage that, how to handle that if there were glitches or anomalies or things we didn't understand. So we had more time to practice with the software. That was one. The other one is when you fly the spacecraft, we were sitting around designing the spacecraft, and we over-constrained it. You know, some of the measurement errors that we were allowing were set too tight. And once we got into space and we were able to open up those measurement errors, the spacecraft flew beautifully. And so we loosened some parameters to let the spacecraft fly. You know, one of those is in the star tracker where you get this eigenvector. This is a non-dimensional term that actually is an association of different parameters. And we set the limits on what that number could be too tight. As soon as we opened it up, the spacecraft flew fine. So we looked at those kinds of things. And then the one thing that certainly we fixed the laser altimeter. That was the first thing fixed before the mission ended on mission 2, but was the orbit determination. And really working out all the kinks in the ground network, all the big radio astronomy dishes around the world, making sure all the timing signals were right, making sure that system put the right output out in terms of a measurement, making sure the measurement format was right, making sure we process those measurements to get a good orbit determination. Because knowing where you are in space, as you get farther away from the Earth, closer to the moon, is of critical importance. And so we made sure that we had that for us. And so those were the things that rose to the top for me.
And again, that was Steve Altimus with Intuitive Machines. Now T-minus 1 hour, 5 minutes, 30 seconds and counting to the planned liftoff of IM-2 from Historic Launch Complex 39A. As we're closing in on an hour out from the liftoff of this Falcon 9 rocket, I want to take a moment, thank the 4,600 of you who are joining with us live at this point in the countdown. If you haven't already, certainly appreciate it if you could hit that like button, share the stream, allow some more folks to find their way into this live launch coverage. I also want to thank a few folks for their support. Our thanks to James Fowley for being a channel member with us for now 7 months and counting. James asks, will there be a stream for the landing? If that question is in relation to the landing of this particular mission for the Nova C, or perhaps you're talking about the Blue Ghost lunar lander, which is set to touchdown on Sunday. The answer to both we're planning on being yes. Still working out some of the logistics on that, but if you haven't already, now's a good time to subscribe to the channel and turn on notifications so that you're alerted whenever we do start our next live broadcast. Also, don't forget there is another Falcon 9 rocket that is scheduled to launch tonight from over at Space Launch Complex 40 at Cape Canaveral Space Force Station. Back-to-back scrubs for that mission. Hopefully the third time tonight will be the charm. That is Starlink 12-13, carrying 12 Starlink satellites to low Earth orbit, 13 of which have direct-to-cell capabilities. We'll start our live coverage on that mission about an hour ahead of liftoff. I also want to thank Astro Joe, one of our moderators, for joining us with moderation in the live chat, but also for gifting a Spaceflight Now membership. Appreciate you, Astro Joe. To our newest channel member, welcome aboard. We're glad to have you with us. If you haven't already, be sure to thank Astro Joe in the live chat, and we hope you decide to stick around with channel membership. As you can see, a small crowd starting to gather here at the press site as we are now T-minus 1 hour and counting to the planned launch of the fourth mission to support NASA's Commercial Lunar Payload Services, or CLPS program. As we are now at the top of the hour for the countdown, go ahead and welcome in everyone who may just be joining at the hour out mark. I'm Will Robinson-Smith, reporter with Spaceflight Now, and you're watching our live coverage of the IM-2 mission, Intuitive Machines' second flight heading to the moon, with both NASA science on board as well as a number of commercial payloads from places all around the world, contributions coming in from here in the United States and various parts of the country, as well as a small rover from Japan and some input from the European Union as well. One of the rideshare satellites that's on board, there are 3 of them, is from a company called Epic Aerospace, which is based in Argentina. Also has a presence here in the United States. Taking a look here, this is the main star of today's mission, IM-2. This is the Nova C lander called Athena, the second that Intuitive Machines is going to be sending to the lunar surface, coming up here, liftoff in less than an hour from now. This particular lander stands about 4.7 meters or 15.5 feet tall with a hull diameter of 1.6 meters or 5.2 feet, slightly taller than its predecessor named Odysseus, which launched back in February of 2024. This lander is also going to be aiming for a spot on the moon that's a little bit closer to the South Pole, about 5 degrees north of the true South Pole, at a site called Mons Mouton. It's one of the taller mountains in that region of the moon, fairly large. For a size comparison, it is roughly equivalent to Alaska's recently renamed Mount McKinley, formerly Mount Denali. As we're now less than 20 minutes away from the nominal point at which the SpaceX launch director will make the call on the start of prop load, let's go ahead and take a moment and talk about the countdown timeline for today's mission, as Intuitive Machines and SpaceX are targeting a liftoff for this Falcon 9 rocket coming up at 7:16 p.m. Eastern, 0016 UTC for those around the world. T-minus 55 minutes, 55 seconds and counting. Once the go-ahead for prop load is given, fueling on the Falcon 9 rocket starts at the T-minus 35-minute mark with the loading of RP-1, which is a rocket-grade kerosene, as well as liquid oxygen. RP-1 flows on the first and second stages. That LOX begins flowing on board the Falcon 9's first stage. T-minus 30 minutes is when they start loading cryogenic helium onto the Falcon 9 rocket's first stage. Helium is important because it's used to pressurize the main propellant tanks during flight. Same will happen on the second stage a few minutes thereafter. T-minus 23 minutes is when the second stage RP-1 loading concludes. And at T-minus 20 minutes and 50 seconds is when the strong back chill down process begins. That's when they condition the feed lines prior to second stage liquid oxygen load. Here at pad 39A, we see that manifest as the so-called big vent that'll start at around T-minus 20 minutes and 30 seconds here at 39A. 20 minutes and 30 seconds. And will last a few minutes. Set the stage for second stage LOX load to begin at the T-minus 16-minute mark. Moving right along at T-minus 7 minutes, the chill down of the 9 Merlin engines gets underway. That's when SpaceX flows a small amount of liquid oxygen through the plumbing and turbo pumps. That's important because it helps protect the engines from the risk of thermal shock and damage during the startup sequence. About 6 minutes out, the first stage kerosene tank is full. Then at T-minus 4.5 minutes, we'll see the strong back retract sequence get underway here at the pad. It'll start with the clamp arms that you see just beneath the payload fairings opening up. And then the transporter erector, the strong back, which I'll just take a moment to flip around here. You can see the strong back a little bit more clearly. It's the large vertical structure that's parallel to the Falcon 9 rocket itself. That'll recline a few degrees away from the Falcon 9 rocket and stay in that position until liftoff, at which point it'll pull back in a much more rapid fashion to clear the way for the vertical climb of the Falcon 9. About 3 minutes prior to liftoff, the first stage liquid oxygen tank is full. Same is true on the second stage about a minute thereafter, at which point the Falcon 9 rocket is fully loaded with 1 million pounds of propellant. In the final 60 seconds, as we hear the call that the Falcon 9 is in startup, control of the countdown is handed over from the ground sequencer to the Falcon 9's onboard flight computers, and the propellant tanks are brought up to flight pressure. SpaceX launch director will give their final go for launch T-minus 45 seconds out. The engine ignition command will be issued at T-minus 3 seconds. And of course, if all 9 Merlin engines are healthy and ignite as expected, the command will be given for the hold down clamps to release the Falcon 9 rocket for a T0 liftoff. Once again, coming up here at 7:16 p.m. Eastern, 0016 UTC, T-minus 52 minutes, 44 seconds. Now, T-minus 52 minutes, 20 seconds and counting. We do have confirmation from SpaceX that fueling of Intuitive Machines' Nova C lander named Athena is now complete. SpaceX is in preparation to begin fueling its Falcon 9 shortly. Again, they'll make the official call nominally on the start of prop load, the T-minus 38-minute mark. We're now T-minus 47 minutes, 37 seconds and counting from the planned launch of the IM-2 mission. As we continue to go through this final hour before the planned liftoff, let's talk a little bit more about one of the demonstrations that will take place with this launch. Taking a look now at a rendering of the Micro Nova Hopper, which is named Grace, designed by Intuitive Machines in support with a tipping point grant from NASA. This hopper was named in honor of Rear Admiral Grace Hopper. She was a computer pioneer in her day and a naval officer who designed one of the first compilers and actually coined that term as well. This little hopper stands about 1 meter tall and is less than half a meter in diameter, designed to carry up to 10 kilograms or 22 pounds of science payload on board. Here's a graphic from Intuitive Machines which gives a general overview of what the hopper will be doing while on the surface of the moon. It's designed to make 5 planned hops, including its initial departure from the lander, each one increasing in challenge and complexity. You see it'll start at a 20-meter altitude hop, roughly 14 hours after touchdown on the lunar surface. There will then be a roughly 15-meter altitude hop, and then the third up to 100 meters where it will cruise at that altitude and land outside a permanently shadowed crater. It will then attempt to hop down into the crater and pop back out again to complete its demonstration. All the while communicating back with the lander through another technology demonstration, this one coming from Nokia, which will be helping to prove out the capability of 4G LTE cellular technology on the moon's surface. Earlier this month, or actually technically at the end of January, we had the opportunity to catch up with Justin Kugler. He's the Director of Business Development for Intuitive Machines. We spoke on the sidelines of the SpaceCom conference, which was hosted as it has been in the past in Orlando, Florida. Talked about a number of things where this mission is concerned, but in this part of the conversation, we'll hear a little bit more about the Grace Hopper and what it'll be demonstrating once it begins its mission on the lunar surface.
So really the whole idea behind Hopper is that we can dramatically extend the reach of these exploratory missions, frankly far beyond what you can get with a small rover, which is ultimately limited in how far it can go on its available power and how many data points you can reach. Whereas Hopper really is it's a rocket-propelled drone with multiple kilometers of flight capacity, and so with this Hopper, we want to show that we can land in a relatively safe, flat zone for initial operations and payload deployment, and then launch Hopper to go into a more challenging region like a permanently shadowed crater, collect data, and then fly back out.
And so how far post-landing will that demonstration happen?
So that'll just depend on how all of the checkout goes. We do need to make sure that our rover customers are deployed and that the drill is being appropriately deployed, and then we will launch Hopper once the flight team has determined that it's safe to do so.
And again, thanks to Justin Kugler. We're now at T-minus 42 minutes, 51 seconds and counting from the planned liftoff against the backdrop of a beautiful sunset here on Florida's Space Coast. Not a cloud in the sky right now, which is the reason why the 45th Weather Squadron forecast a greater than 95% chance of favorable weather for liftoff for today's mission. Now T-minus 36 minutes, 40 seconds and counting. Starting to hear some noise from the pad level cameras, or the pad level mics. That's the venting noise that you're starting to hear. Now T-minus 35 minutes, 3 seconds and counting. We are now stepping into the process of fueling the Falcon 9 rocket here. Now T-minus 32 minutes, 6 seconds and counting. If you look just beneath the X in SpaceX and the lettering there, near the center of the rocket, you can see a little bit of vapor trailing away from near the base of the Falcon 9 first stage booster. A frost line is beginning to form as the supercold densified liquid oxygen begins slowly filling that first stage booster. This is a good sign of prop load being underway, which means SpaceX is moving forward towards a liftoff coming up at 7:16 p.m. Eastern, 0016 UTC for those joining around the world. Getting a look now inside mission control for Intuitive Machines, where they're going to be monitoring the Nova C lander throughout the course of its mission on its path to the moon and once it begins operations on the lunar surface. This is at their facilities in Houston, Texas. Nova Mission Control is what they call it. Intuitive Machines has gone through copious amounts of tests, data reviews, and preparation for tonight's launch and the beginning of their journey to the moon, targeting a landing, if all goes well, coming up on March 6th. They will operate for about 10 days until the sun sets on the surface of the moon there around March 16th. These early landers as part of the CLPS program are not designed to survive well into the lunar night. Those will be capabilities coming up on future CLPS missions and future landers. Now T-minus 29 minutes, 30 seconds and counting. At this point, SpaceX will be loading a cryogenic helium onto the Falcon 9's first stage. Helium is important because it's used to pressurize the main propellant tanks during flight. Now T-minus 26 minutes, 35 seconds and counting. I want to thank a few folks for their support in the live chat. Our thanks to Captain Action, marking 2 months with us now as a channel member at the pad leader level. Appreciate the ongoing support, Captain Action, for the kind words. He says, "Will, you're the best. Hit that like button, cousins." Also want to thank my mother, Mary Robinson, for joining us with a very generous super chat. Thanks for watching, Mom. And for those in the live chat, be sure to give a warm spaceflight now hello to Mama Robinson in the live chat. Also want to thank some gifting that's been going on. Moderator Astro Jen joining us with a gifted membership. Also Mark Potachnik gifting a membership as well, and Mark Otto, another one of our moderators, gifting 10 Spaceflight Now memberships. So to our newest 12 channel members, welcome aboard. We're glad to have you all with us. If you haven't already, be sure to thank Jen, Mark, or the other Mark in the live chat. And we hope you decide to stick around with channel membership. Also want to thank Disco Biscuits and Campbell on Top for a $2 and £2 super chat, respectively. Campbell on Top checking in from Scotland. If you haven't already, hop into the live chat. Let us know where you're watching this moonbound mission from. Whether you're here in Florida with us, hoping to see it with your own eyes, or you're relying on our views here to bring you an up-close vantage point of this Falcon flight. Currently T-minus 24 minutes, 44 seconds and counting to the planned launch of this Falcon 9 rocket. At this point in the countdown, SpaceX is loading cryogenic helium into the storage tanks on the second stage. Time now T-minus 23 minutes, 45 seconds and counting. As I mentioned earlier in the broadcast, the Falcon 9 first stage booster that'll be launching today's Falcon 9 flight. Tail number 1083 in the SpaceX fleet. It's going for its 9th launch in its history, so before it gets to that milestone tonight, let's take a step back in time and talk about where it's been so far. Its first mission was in support of human spaceflight up to the International Space Station, with the launch of NASA's Crew 8 quartet up to the orbiting outpost that lifted off on March 4th of last year. That was followed up by the Starlink 6-48 mission on April 10th. Another Starlink flight, 6-56, on May 8th. Another human flight for this booster, Polaris Dawn, lifting off on September 10th of 2024. Notable, of course, in retrospect, as Polaris Dawn was commanded by Jared Isaacman, who also commanded the Inspiration 4 mission and has been nominated to be the next NASA administrator. No confirmation hearing date has been scheduled just as of yet, but that will be coming up here in the weeks to come. Next up for this booster was CRS-31, which flew on November 5th of last year. Back to Starlink land with Starlink 6-65 on November 30th. A quartet of satellites for Astronus, their Block 2 flight lifting off on December 29th of last year. And most recently, this booster launched the Starlink 13-1 mission on January 21st. Now T-minus 21 minutes, 50 seconds and counting. We are coming up on the process where SpaceX will condition the feed lines at the pad prior to second stage LOX load. One of the big visual mile markers of any Falcon fueling. See the so-called big vent here start around T-minus 20 minutes and 30 seconds, so we're just about a minute out from that event. Now T-minus 20 minutes, 22 seconds and counting. You can see the big event is now kicking off there at the pad. Again, SpaceX is conditioning the feed lines prior to second stage liquid oxygen load.
Stage 2, RP1 load complete.
And a good call from SpaceX as well. Now T-minus 16 minutes, 38 seconds and counting. We're coming right up to the end of the big vent here. SpaceX is preparing for second stage liquid oxygen loading.
Stage 2 LOX load has started.
And a good call out from SpaceX. Now all parts of tanking the Falcon 9 rocket are in work. Time now T-minus 14 minutes, 9 seconds and counting. As promised, now that we're in the second and final pre-launch hour of our coverage, let's go ahead and turn back to the trajectory for today's mission. Talk about where this Falcon 9 is going to be flying once it leaves the pad. After liftoff from LC-39A, the Falcon 9 rocket supporting today's IM-2 launch will head in an easterly direction, flying away from Florida's Space Coast. Unlike the first time it launched an Intuitive Machines Nova-C lander, this Falcon 9 first stage booster will not return to a landing site at Cape Canaveral Space Force Station, but instead will target a landing on the SpaceX drone ship called Shortfall of Gravitas. If successful, this will be the 100th booster landing for that particular drone ship, as well as being the 413th booster landing to date. SpaceX is working to certify its payload fairings for up to 40 flights, same as the boosters. They'll splash down into the waters of the Atlantic Ocean under the support of steerable parachutes, as you see in this image here from SpaceX. The company saves about $6 million per recovery effort, so it's an important part of their business model to retrieve these fairing halves, refurbish them, turn them around for future flights. They'll be brought on board one of these recovery vessels, brought back into Port Canaveral, and then over to the Hangar X site where that refurbishment work will be done. Now T-minus 12 minutes, 8 seconds and counting. We talked about the countdown timeline early on in the broadcast. Let's go ahead now and pivot to the launch timeline, the sequence of events that we're expecting with a nominal flight of the Falcon 9 rocket and deployment of its payload. Liftoff tonight, targeting 7:16 p.m. Eastern, 0016 UTC. About a minute 18 seconds after liftoff, the Falcon 9 rocket will pass through max Q, which is the point of greatest aerodynamic pressure on the vehicle. There will be a few events after that in fairly rapid succession. We'll see first stage main engine cutoff, or MECO, when all 9 Merlin engines will conclude their initial burn. The first and second stages will separate a few seconds after that. And then the Merlin vacuum engine on the second stage will begin its first burn at T plus 2 minutes and 42 seconds. The payload fairings that are protecting the Nova C lander, as well as the 3 rideshare spacecraft, will be deployed about 3.5 minutes post liftoff. 3 of the engines on the first stage will reignite for an entry burn lasting roughly 26 seconds, starting at about T plus 6 minutes and 15 seconds post liftoff. The upper stage engine will conclude its first burn, SECO 1, just before the 8-minute mark. And then seconds later, the first stage landing burn will begin, where SpaceX will use just one of the Merlin engines at the heart of the Falcon 9 first stage booster to bring the booster down for an attempt at a soft landing on the drone ship about 8.5 minutes post liftoff. Moving right along, there will be a second burn of the upper stage engine, which starts at the T plus 36 minutes 25 second mark. That burn lasting just a hair over a minute in duration, setting the upper stage on the correct trajectory to deploy the Athena lander at T plus 43 minutes and 38 seconds. There will be a few minutes post separation before we see the rideshare payloads begin their journey. AstroForge's Odin spacecraft, which will be doing a flyby of an asteroid, that will be setting off on its own at T plus 47 minutes 28 seconds. Then the Lunar Trailblazer will actually be deploying at T plus 47 minutes and 48 seconds. A little bit of a typo there. But then Epic Aerospace's Chimera GO1 spacecraft will deploy at T plus 48 minutes and 8 seconds, bringing the IM-2 mission to a close. Of course, all the spacecraft will go through the process of acquiring signal between their various mission control centers around the country and the spacecraft that are beginning their journey. And at the point at which the Intuitive Machines Nova C lander separates from the Falcon 9's upper stage, there will be 3 distinct landers en route to the moon simultaneously, something that has never happened before, and ushering in of a new era in the cislunar economy.
Spacecraft is go for launch.
And a good call from SpaceX that the Nova C lander is, from their team's point of view, go for launch. And T-minus 7 minutes, 6 seconds. We'll next hear the call for the Falcon 9's engine chill.
Engines are chilling in for flight.
Good call by SpaceX. As we are cruising through these final few minutes of the countdown, it's been a very smooth and quiet count for SpaceX. in about 30 seconds or so, the first stage kerosene tank should be full. That RP1 we mentioned.
Stage 1 RP1 load complete.
Good call out. Just 6 minutes to go before the planned liftoff of this Falcon 9 rocket. All that's remaining as far as fueling now is the liquid oxygen on board the Falcon 9's first and second stages. In roughly a minute, we'll hear the call that the strong back is pressing for its retract sequence. Start by seeing those clamp arms just beneath the payload fairings open up, and the transporter erector, the strong back, which runs along the backside of the Falcon 9 from this perspective. Taking a quick look at our friend Pete Karstens with MaxQ Productions, his camera, you can see it's the vertical structure that is parallel to the Falcon 9. That'll recline a few degrees away from the vehicle.
Tanks are pressing for strongback retract.
Good call from SpaceX. As we're waiting to see those clamp arms start to move, I want to thank a few folks in the live chat who are supporting us tonight. Our thanks to Duck Duck for a $2 super chat, who says, everyone in the chat is awesome. Also, rocket time. Ryan Snyder with a $5 super chat, one of our wonderful channel members.
Strong back retract is running.
Good call there. Watch for the movement of those clamp arms. Ryan says, love this channel and Spacefly Now family. Thanks to Sherry Barnes for a $5 super chat as well. And want to welcome in some new channel members. Gerard Bernaccia joining us with membership at the pad leader level. Also some gifting going on here, I see. Glenn A., Ryan Snyder, both gifting a membership apiece. And Dawnfleet gifting 10 Spacefly Now memberships. Appreciate that generosity from all of you. Could start to see the transporter erector moving back away from the Falcon 9 rocket just a little bit.
Stage 1 LOX load complete.
Good call from SpaceX. We're now just awaiting a similar call on the second stage.
Stage 2 LOX load complete.
With that call from SpaceX, the Falcon 9 is now fully loaded with 1 million pounds of propellant.
Ground gas closeouts.
Good call there as SpaceX is removing the remaining liquid oxygen from the lines. Now just about a minute from launch.
Falcon 9 is in startup.
Good call from SpaceX. We're now just awaiting the SpaceX launch director to give their final go for launch, which should be coming here momentarily.
LD, go for launch.
"30 seconds out. "20 seconds. 15 seconds. And here we go. In 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff of the Falcon 9 rocket on the IM-2 mission for Intuitive Machines. Falcon 9 has cleared the tower. Now a little more than a minute to flight. The Falcon 9 now traveling faster than the speed of sound as it approaches max Q, point of greatest aerodynamic pressure on the vehicle.
Max Q.
Soon SpaceX will begin conditioning the Merlin vacuum engine for the start of its burn. Some great work by our tracking team today. As we approach the second minute into flight, we're coming up on 3 milestones in fairly rapid succession. We'll see first stage main engine cutoff, or MECO, followed by stage separation, and then the ignition of that Merlin vacuum engine. It goes about 15 seconds from now.
MECO.
Stage separation confirmed.
And vac ignition.
And a really nice view of an orbital sunset. Good callouts, good views from the SpaceX onboard cameras as well. Now 3 minutes into flight. The payload fairings will be deployed here in just about 20-ish seconds.
Fairing separation confirmed.
And a good call, good views of fairing separation.
Vehicles are on a nominal trajectory.
Now a little more than 4 minutes into flight. Next milestone coming up here is going to be the first stage entry burn, when 3 of the Merlin engines on the first stage booster will come back to life. Begin to slow the vehicle down dramatically. Now, a little more than 5 minutes into this mission, everything appears to be moving nominally. Still have good tracking views from our friend Pete Carstens with Max Q Productions. Once again, we're coming up on the start of the first stage entry burn, which will begin in about 25 seconds. Given the clearness of tonight's launch conditions, we may be able to catch that entry burn with our tracking cameras. We'll make a try at it, and of course, if we're able to see that view, we'll...
Stage 1 entry burn startup.
Stage 1 FTS is saved.
And Pete Carson's has that entry burn. Well done, Pete. Those 3 engines concluding their burn now.
Stage 1 entry burn shutdown.
Seeing that view from the Falcon 9's onboard camera. Turning now to the glow of the Merlin vacuum engine on the second stage as we approach 7 minutes into flight. Next milestone will actually be the conclusion of the upper stage's initial burn, SECO 1. That'll be followed about 6 seconds after that by the start of the landing burn. Now, unfortunately, this event is too far away from us to low to the horizon for our tracking cameras to be able to see, so we'll be relying on SpaceX's onboard cameras to provide views of the landing
Stage
attempt
2's terminal guidance.
on the drone ship. And our friend Chuck Briggs still just managing to hang on to views of the
Stage 1 transonic.
Merlin vacuum engine's glow on the second stage.
Stage 2 FTS is saved.
That call from SpaceX, the Flight Termination System, or FTS, no longer needed at this stage in flight.
And vac shutdown. Stage 1 landing burn.
Nominal parking orbit.
Landing leg deploy. Stage 1 landing confirmed.
And for a 9th time, a good landing for B-1083. This particular booster landing, another milestone for SpaceX, as this marked the 100th successful booster landing on that drone ship, a short fall of gravitas. Now 9 minutes into flight, the upper stage continues to coast. You got a good look now at some of the payloads on board. In the foreground, you're taking a look at AstroForge's Odin spacecraft. This is a look inside the Nova C lander. This is its main engine, tucked inside the adapter there. At the top of the stack is the Intuitive Machines Nova C lander. Again, this is a look at their main engine. Touchdown on the lunar surface about 5 degrees north of the lunar south pole at Mons, Bhutan, scheduled for March 6th. So just a few days after the planned landing of Firefly Aerospace's Blue Ghost lunar lander. Taking a dip into this view away from the upper stage. This is an animation of NASA's Lunar Trailblazer spacecraft, one of the rideshare that's on board this particular Falcon 9 flight. This mission is headed up by NASA JPL, the Jet Propulsion Lab in Pasadena, California. The spacecraft that you see there on the left-hand side, try to point it out faster next time SpaceX toggles back to that view, but that is the Lunar Trailblazer in its launch configuration. Currently at T plus 13 minutes, 30 seconds and counting. The next milestone coming up here is going to be the reignition of that Merlin vacuum engine that you see there in the center of your screen. That's coming up at T plus 36 minutes and 25 seconds. Time now T plus 14 minutes, 58 seconds and counting. In the run-up to this mission, we had the opportunity to speak with a representative of the company that built the Lunar Trailblazer, that spacecraft on the left-hand side of your screen right now. That's Lockheed Martin's space division. We spoke with Tim Preiser, who's the chief engineer for deep space exploration at Lockheed Martin, talking about the mission for Lunar Trailblazer and the way that this mission has come about. So again, this is part of our conversation that we had yesterday with Tim Preiser.
NASA has done a great job with these ride shares as far as cost efficiency and getting these types of missions, and specifically this kind of science for this kind of cost, to somewhere outside of a lab on this planet. So we're taking two very powerful science instruments to the moon for the fraction of the cost of what it would take if we had to send this by itself. We will get to the moon in 4.5 days. We'll be racing IM-2 to the moon. IM-2 actually gets to land. When it gets there, we will use the gravity to assist us back toward the Earth. And then we'll use the Earth to actually give us another gravity assist into a much larger orbit that allows us to start to synchronize with the moon in its lunar orbit about the Earth. And that whole process is going to take 3 loops in these orbital mechanics in 4.5 to 5 months. So imagine that we actually get to the moon in 4.5 days, but we actually don't get into our science orbit for 4.5 months. And then once we do capture, we will be able to map the entire surface of the moon, and it repeats every 6 months. So for 20 months, we'll be mapping the moon and figuring out where the water is, what form it's in, and how much there is.
And our thanks again to Lockheed Martin and Tim Preiser. Those two instruments that he was mentioning, one is the High Resolution Volatiles and Minerals Moon Mapper, or the HVM3, a JPL-developed imaging spectrometer. The other is the Lunar Thermal Mapper, or LTM, which is developed by the University of Oxford in the UK, which helps to detail the temperature properties on the moon's surface. In our conversation, Tim mentioned that they will be able to make about 2 full mappings of the moon, which will be important because it, on the first pass, will show where they're detecting signs of water in one part of the moon, and then given about 6-ish months difference with the second full go around, they'll be able to tell if there's any movement of where the water is on or just below the moon's surface, and that'll help to characterize things, as NASA, of course, is looking to establish a permanent human presence on the moon through its Artemis program. Now T minus 18 or T plus 18 minutes, 25 seconds and counting. Little less than 20 minutes away from the second burn on that upper stage. Time now T plus 19 minutes, 49 seconds and counting. As we continue to track the progress of the Falcon 9 upper stage and its payloads on board, let's take a quick moment to thank some folks in the live chat for their support tonight. Our thanks to Monkey Tree Rob for a $5 super chat, who says, "Been a while, but back, and always enjoy this group. Thanks, Will, and all the crew for bringing us all into the space world." Thank you for the kind words, Monkey Rob. Good to have you back. Also thanks to the Space Dinos for a $5 super chat, who says, "Happy travels." Channel member Wolverine Warlord with some generosity here, gifting 5 Spaceflight Now memberships. Appreciate that, Wolverine. And to our 5 newest channel members, welcome aboard. We're glad to have you with us. If you haven't already, be sure to thank Wolverine Warlord in the live chat, and we hope you decide to stick around with channel membership. Another one of our members, Rolly Nevels, been with us now for 8 months at the mission specialist level, with some kind words saying, "This is the greatest group chat on the internet." That is high praise. There's a lot of group chats on the internet. Thank you all. Thank you, Will Robinson, and cheers to the best and most knowledgeable moderators. And I'll second that here to a great group of moderators helping us out this and all of their days. Thanks as well to channel member Skunk Hogger PS4, the $10 super chat. It says, "Watching tonight from the big bump in the road on I-10. Hope you were able to get a good view of the Falcon 9 as it made its climb uphill." Brian Dean Ulrey with a $2 super chat saying, "Ad Astra." Wolverine Warlord also marking 17 months with us as a channel member at the launch director level, who says, "Let's light this candle, baby. Woo! Go SpaceX." Campbell on top with a £2 super chat. Thank you, Campbell, who says, "Go for launch." Obviously coming in before liftoff. Viewer with the simple moniker of R with the $10 super chat. Thank you, R, who says, "Let's go IM-2. Godspeed." And Intuitive Machines heading to the moon. And also want to welcome in our newest channel member, Carl Schulter, joining us with channel membership at the path leader level. Welcome aboard, Carl. Glad to have you with us. Time now T plus 24 minutes, 59 seconds and counting. Once again, the next milestone coming up for this IM-2 mission will be the second burn of that upper stage engine, which will begin in roughly 11 minutes at a T plus 36 minutes and 25 seconds into flight. Assuming a good landing of this Nova C class lander named Athena from Intuitive Machines, there will be a number of technology demonstrations in addition to the science that'll be displayed on the lunar surface. Part of that comes from a familiar name for those who have had one of their products, Nokia, who is going to be demonstrating 4G LTE connectivity on the moon through not only the rover, which is being provided via Nokia to this mission, but the map rover comes from a company called Lunar Outpost. Nokia will also be connecting to the micro Nova hopper called Grace. Prior to launch, we had the opportunity to talk with Thierry Klein, who is the president of Bell Labs Solutions Research, research division within the Nokia company. And we talked about connecting between both a rover and a hopper and what some of the challenges might be. And surprisingly, he says that it's kind of all the same to them, just in a different manner of speaking, but I'll let him make the analogy for himself.
It's actually not that different from a communication perspective. It's akin to your smartphone connecting to your service provider network when you're walking or when you're in a car. So the technology allows to support devices that are at different speeds. So we don't think that that's necessarily a challenge, whether the rover drives very slowly or the hopper hops over the distances. They cover very different distances. So that is not a challenge for the technology. There's other challenges, but the difference in speed is not one, and it's very akin to what you see on terrestrial deployments.
So what are some of the challenges in your mind?
So I think one of the challenges is we built the system on standards-based technologies, but we had to make a lot of engineering changes. One is we had to really optimize the swap, size, weight, and power. So we've done massive integration on the hardware and the software side to get the size of the equipment down to something that's the size of a small pizza box. So massive integration so that we really optimize it from that footprint perspective. Because a terrestrial cellular network will have a large capacity, will support hundreds of thousands of connections. We don't need that. So we dimensioned the system for what we need for this mission. So that's the first one. The second one is really using commercial technologies and commercial components, but still hardening them from an environmental perspective, whether it's shock, vibration, acceleration, the mechanical stresses during launch and landing, as well as temperature, and radiation effects. So we've built it on commercial components, but we've done some hardening for the environmentals. And then the last part I would say is really, it's an autonomous network. The IM-2 mission is uncrewed, so this network has to be completely self-deploying, self-operating, self-configuring, and self-healing. So we have the network is actually a dual hardware redundant system. If one would fail, it automatically switches over to the next one. So we built a lot of software reliability into the system because there are no technicians that can configure it. And we have control capabilities from mission control, but we really want this network to be self-deploying, self-configuring.
And again, thanks to the folks over at Nokia for sitting down with us ahead of the launch of the IM-2 mission. As we're watching the coast of the upper stage of the Falcon 9 rocket, if at any point you would like some more context and to read at your leisure, we do have a mission preview that we posted on our website, spaceflightnow.com. It's at the top of the main page, and it has an overview of the lander, the hopper, talks about the rover, technology on board, the Prime 1 mission from NASA, the Polar Resources Ice Mining Experiment 1. Now T plus 30 minutes, 9 seconds and counting. Just about 6 minutes away from the reignition of that Merlin vacuum engine. Time now, T plus 33 minutes, 14 seconds and counting. As we are awaiting the reignition of that Merlin vacuum engine, you can see it's beginning its chill process prior to its second burn. I want to thank some folks in the live chat for your support tonight. I want to thank JoJo Mo 443 for our $5 super chat. Some kind words saying best channel for launches. Thank you. Astro Engineer has been a channel member with us now for 2 months at the pad leader level. Glad to see you still with us, Astro Engineer, who says, thanks Spaceflight Now crew for this amazing broadcast. Go SpaceX. Miles Schumann with a $10 super chat. Thank you, Miles. Says, thanks so much for your work. Channel member Mel Roberts Harold with a $10 super chat. Thank you, Mel. Good to see you this evening. Says, shout out to Michael and Uncle Al. Watch the launch from the backyard. And want to welcome Kimberly Hertler, join us channel membership at the piloter level. Now T plus 36 minutes, 13 seconds and counting. We're about 10 seconds away from the Merlin Vacuum Engine's second burn beginning.
And vac ignition.
Good call there. This burn will last just a hair over a minute in duration. Less than 20 seconds left on this burn.
And vac shutdown.
And a good call out there. The conclusion of this burn.
Nominal orbit insertion.
And with confirmation of a nominal orbit insertion, we are approaching the point when the IM-2 lander will be deployed. That's coming up here at T plus 43 minutes and 38 seconds. Before we get to that point, though, want to play you one more video, though, not connected to the lander, but actually one of the rideshare payloads that you're seeing right in the middle of your screen, the one that is clad with gold on the right-hand side from that angle. That is Odin. This is an asteroid viewing mission, I'll phrase it like that, from a company called AstroForge. In the run-up to launch, we had the opportunity to speak remotely with AstroForge's CEO about this mission. This is their second operational flight. First time flying as a rideshare payload on a transporter mission, this time, of course, as part of IM-2. So this is part of our conversation with Matt, the CEO of AstroForge.
So the particular class of asteroids is very important, right? Because these metal asteroids, we believe, are going to be very, very high in the concentration of what are called the platinum group metals. And at the end of the day, we're a mining company that needs to be able to sell material, right? We want to sell material on Earth into a market on Earth that has a value today. And that market is the critical minerals, specifically the platinum group metals. It's a massive market, and that's what we care about. It doesn't exist on the moon at any kind of concentration that's worth it. It doesn't exist on S-type or C-types. But it's in really high concentration on M-types. And so number one is we got to make sure we're finding an M-type, right? If we go to a different type of asteroid, like, doesn't matter, I got to an asteroid, great, but if I can't, at the end of the day, if I can't build a business around that, who cares? I'm sure there's people that care. There's going to be a scientific community that's cared. Scientific communities don't run businesses. And so we always got to keep our foot on that idea of like, how are we a profitable business at the end of the day? And that's going to a metal asteroid. Yeah, so about 45 minutes after launch, we get thrown off the side of Falcon. And then it's all on us, so hopefully we don't screw it up. We go into, we have a timer on there. I think it's 60 seconds we need to wait before we do anything. Probably a little bit off on that, whatever it is. And then we go into a mode where it's essentially what we call sunset. It's find the sun and point the solar panels on it so we become power positive and start transmitting. Then we will pick up the spacecraft and we will do essentially functional checkouts. Make sure we survive the launch. And if we didn't, try to understand what is screwed up and see if there's a path forward to fix it. Over the next day or two, we do a lot of ground-based observations to get a trajectory path of the spacecraft. We want to understand where we actually got deployed from Falcon. There's always going to be some noise around that deployment, and some of the edge cases have us hitting the moon, which is always kind of comical to think about. Some of us have us going way too far out, and so we got to determine right away if we need to do what's called a correction burn within the first 72 hours. There is a chance we don't have to, and we will just fly past the moon and then do our burn. So at about day 5, we pass the moon. And about day 6.5, we have attempted doing a burn to actually put us on a course to intercept the asteroid. So we'll do that. And then about 2 weeks after that, we really do nothing and we go into a coast mode. And we're coasting for about 9 months. We'll wake back up about 2 weeks before we get to the asteroid. Do this maneuver to kind of lock onto the asteroid, right? We have to do some local navigation because we just don't know where the asteroid is with close enough air bars to do a very quick flyby. And then perform the flyby, take the images, and send them back to Earth. That's the plan of the mission. We'll continue to talk to the vehicle, or at least listen to the vehicle until it dies. And that's to just get a better understanding of the core bus concepts and how radiation tolerant we are in certain things, if the risk we took in certain levels was correct or not, and how long this vehicle can last for. One of the things I'm a big proponent of at the company is we want every mission to be 2 years. And so to be clear, if we get out there in 20 years from now, I'm like, oh, this mission is still working, like, we're wrong. It is not meant to be overbuilt. It is meant to be as cheap as possible to give us that mission profile of 2 years. And that's a big deal to me as we go out there with the team.
And our thanks again to Matt Gallick, the CEO of AstroForge. Now T plus 42 minutes, 24 seconds and counting. We are just about a minute away from the deployment of Intuitive Machines' Nova C lander. It's, of course, an exciting moment that the folks at IM have been building towards for quite some time now, taking all the learnings from their first lunar mission, IM-1 and Odysseus, and applying it forward to Athena, who's about to take its first leaps on its own, coming up here. Deployment happening in less than 40 seconds. About 10 seconds away from deployment. And a good deployment of the IM-2 Nova Sea lander, Athena. Of course, this mission isn't over since those rideshare payloads that you see there remaining on the Falcon 9's upper stage are still needing to be deployed.
IM-D on IM status.
Any open work on Singapore?
COA. We have LV set.
All right.
Payload deploy confirmed.
FM, can you call out when we should have booted? And then if we get close to Confitter, give us a call.
Athena separation confirmed.
Okay.
Taking a live look now into the control room. Nova Mission
And
Control.
Com and Raven, let's tell Scuba to stand by and let's focus on Singapore and TNOC.
Understood.
Hearing some call-outs, believe from Nova Mission Control as they're looking to acquire the first signals from the Athena lander.
My timer is at 1 minute 40 seconds post LV set.
Procedure says 1 minute 47 is the earliest time for transmit. We are at 1 minute 55.
All right, copy.
Granite, keep active comm. Give us anything you got from the ground station.
AD permission back to TNOC for a second.
You have a go.
T plus 46 minutes, 49 seconds and counting. His teams with Intuitive Machines are waiting to acquire signal from the Nova Sea lander. We are about 30 seconds away from the deployment of AstroForge's Odin spacecraft. This will begin a sequence of rideshare deployments with 20 seconds in between each separation. First Odin, then the Lunar Trailblazer, and finally Chimera Geo 1.
Odin separation confirmed.
Odin now beginning its journey for an asteroid flyby mission. Lunar Trailblazer is next.
White MD, IM status, Odin
Lunar
away.
Trailblazer separation confirmed.
Lunar Trailblazer away.
Finally, Chimera Geo 1, the lone spacecraft left.
Chimera Geo 1
Yeah,
separation
Com, we
confirmed.
will have an OEM for them. Priority right now is Singapore.
Chimera away.
Understood.
All spacecraft are separated.
4 minutes 15 seconds past set.
All right.
Very dynamic point in the mission for SpaceX and Intuitive Machines. As you saw, the 3 rideshare payloads successfully deploy. Those teams will also begin work to acquire signal from their respective spacecraft. Eyes are still on.
White MD on IM status, waiting for 1909 for our window to open for visibility on the first station.
We're still standing by for connection with TNOC, is that correct?
That's good feedback.
Gronet, should I enable randomization? Copy that.
Intuitive Machines has a network of ground stations positioned around the world to help keep in touch with the Nova C lander once signal is acquired.
I have 6 minutes post up.
Copy that.
In COM, we're expecting 1909 for the visibility.
That's correct.
Seven minutes, 25 seconds past up.
Copy that.
We are halfway to trip and fitter.
I understand. We should be getting a call shortly from TNOC to connect.
Right now, teams with Intuitive Machines, as well as the other 3 rideshare payload teams, are all awaiting.
Talk to me, Goose. Ground out, what are we seeing? Is T not giving you any feedback?
They're awaiting acquisition of signal with their spacecraft.
COM, while they're working that, when is visibility open for Okinawa?
1:29.
What about DSS 34?
1:15 in 5 minutes.
We are 9 minutes, 30 seconds past that.
Copy that. And FM confirmed 15 minutes, and it just swaps Thales, right? Okay. Copy. All right. We got 5 minutes to confetter there, Super Dave. So if you think we can do that and get at least a Farm B up there, that would be great.
Time now T plus 55 minutes, 9 seconds and counting. Still watching and waiting for acquisition of signal from Intuitive Machines to its Athena lander. Right now they're working to ensure that their projected trajectory aligns with their actual trajectory for where the upper stage of the Falcon 9 rocket sent the Nova C lander. At the same time, as we mentioned, this is not the...
Groundnet, how long would it take us to configure the DSN data connection?
Go ahead and turn it on. It should be on now.
Okay, Groundnet.
DSN is, of course, the Deep Space Network.
Just passing 12 minutes in SEP. We have 4.5 minutes before fitter trips.
Copy, thanks FM.
Groundnet, 3 minutes. Let's move.
Want to take a look at another mission control that is also tracking
34.
the progress of its satellite. Taking a look at the live feed from AstroForge.
Start bend.
You can see their mission control in the upper left-hand corner of their screen. The green dots in the bottom left-hand.
I have command active for DSS 34.
All right.
Telemetry. Setting command off. Enabled DSS 34B. I have telemetry active.
All right, are we getting updates?
I don't see packets yet.
$14 minutes past that.
All right, Groundnet, what do we need to do to get telemetry packets?
I'm not sure. We should be seeing them now.
All right. All right, so while TNOC is working, looking for anything we can shake on the DSN side to get packets.
FM, so we're expecting about a minute for the power cycle, and then another 15. Sitting there looking, same antenna config.
30 seconds to the power cycle is what I got.
Copy. Okay.
Call it out, we'll start a timer.
It's just added on to the original one.
Yeah.
We're at 16, 17 is what I'm showing. Is that what we got?
I'm now at 16, 17 right now.
Okay.
Copy.
Granite, give us calls on the main loop. You are the most important person in the room. Everything you're doing is critical. Call it on the loop, everything you see.
Copy that.
Background net, everything goes on the main loop between you two.
Copy that. So I see you're blind on DSS 34B. Do we have Condor in the room?
Condor, you on IM-1? Where you at?
Condor's in back room with Raven.
Yep. Granite, what do you need from Condor?
I need them to check the data control to make sure they're seeing packets flow to us.
They have carrier lock, subcarrier lock, symbol lock, but no telemetry.
But they have no telemetry.
Copy.
Okay, that's different. I need to borrow somebody's phone.
We have Colin.
Showing packets.
I have packets.
All right, everybody start looking through your systems.
Everybody wake up.
I've got data.
I don't. Go ahead, Tina.
I have AFM in transit pointing mode.
Com, let's get Farm B so we can reset things.
Yeah, it looks like there's a system command in the queue.
Yes, sir.
Orange Coronet, can I enable telecommand for DSS 48?
Okay, did we just lose packets?
Loss of packets.
Copy.
Okay, we got a snapshot. Everybody take a look at what you got.
Taking a look at the live data coming through the Deep Space Network from NASA. There was a signal. Now you heard the call for loss of packets just a moment ago. DSN starting to receive signal again from the Nova C lander. Time now T plus 1 hour, 6 minutes, 3 seconds and counting into this flight. Still getting live views for the time being from NOVA Mission Control there in Houston, Texas. Just for a quick recap, we've seen a bit of the signal coming and going as projected by the public-facing data from NASA's Deep Space Network, which is managed by the Jet Propulsion Laboratory. Also keeping tabs on any signal coming through to the Lunar Trailblazer. Haven't seen that pop up just yet either. At this point, we're going to go ahead and begin to wind down our coverage. We'll, of course, continue to monitor for the very latest from all 4 of the independent spacecraft that are now flying and working on getting towards their goals here. Just checking for some updates. You see within the last 30 seconds, an employee who works operations at the Canberra Deep Space Communications Complex says, and I'll quote him here, all 3 Canberra antenna now have had good acquisitions, both IM-2 and Trailblazer looking great. So some good updates from that part of the Deep Space Network. Of course, we're continuing to keep tabs as well on AstroForge's Odin spacecraft, as they are still in the process of tracking the health of their spacecraft, Odin, which will be making a flyby of what they believe to be an M-class metal asteroid. Also watching out for additional updates from the folks at Epic Aerospace on their Chimera GEO-1 spacecraft. Before we go ahead to our mission stats that currently stand, I want to thank a few folks in the live chat. Our thanks to RJ News for a $20 super chat. Saying Richard and Cheryl from our news desk in Tulsa, Oklahoma, wish you all the best. And Don Flea with a $10 super chat. Thank you, Don. Closing out as we always do with a look at the mission stats as they currently stand. IM-2 was the 9th flight of that Falcon 9 first stage booster, B1083. Marked the 441st Falcon 9 launch date. 24th Falcon 9 launch of 2025. The 25th coming up here in just a couple of hours over at Pad 40, Cape Canaveral Space Force Station. This was the 384th Falcon booster reflight, or the launch of a booster that has flown at least once. This is SpaceX's 24th orbital launch of the year, given that there have been no Falcon Heavy missions to date. 140th within the last 365 days. This was the 104th orbital launch from Pad 39A, and the 198th overall orbital flight from that pad as well. Taking a look at the bar chart here, this is where SpaceX stands year over year. Moving down to some recovery stats, this was the 100th landing of a booster successfully on the drone ship, a shortfall of gravitas. That marked the 331st SpaceX drone ship landing and the 413th overall orbital SpaceX booster landing as well. Finally, with some industry stats, this was the 18th orbital flight from the Sunshine State, 25th overall launch from U.S. soil, 27th from a U.S. rocket company, and the 38th global attempt from around the world. So far, there have been no failures to deploy the respective payloads on these flights. Here's where the pie chart now currently stands. And we're going to take just feels like it's going to be a very brief pause in our live coverage as we stop down, reset, unplug things, replug them back into a different place as we prepare for the launch of SpaceX's other Falcon 9 ready to fly, the liftoff of hopefully Starlink 12-13, which has faced a couple of scrubs in the last number of days, so hopefully all is in a good position for a liftoff tonight. That Falcon 9 looking to fly from Pad 40 here, coming up again just in a matter of hours. Liftoff currently set for 10:34 p.m. Eastern. 0334 UTC for our friends joining around the world. Last note goes to our moderator, Clistia Lee, with a $10 super chat. Appreciate you, Clistia, saying donation to Will's Hall and Teas Fund. After tonight, I'm probably going to need all of the halls, all of the tea. I want to thank Calistia as well as our other moderators who've been helping us out in the live chat today. Our thanks to Astro Jen, Rick Donner, and the crew for being with us today, helping us out in the live chat. I want to thank our Spacefly Now editor, Stephen Young, for running the technical operations of the broadcast. Thanks to Michael Kane for his still photography, which you can check out on his social channels. We'll have that up on ours as well, simply at Spaceflight Now. Thanks to our friends P. Carstens with Max Q Productions and Chuck and Jen Briggs for their help in tracking the Falcon 9 as it took flight. Most importantly, though, thanks to you for wherever you've been watching from as Intuitive Machines endeavors to make a second landing on the moon, kicking things off with the launch of IM-2 an hour and 15 minutes ago. For all of us here at Spaceflight Now, I'm Will Robinson Smith. Remember, be good to yourselves, be good to others, and we will see you next time, folks. And until then, bye-bye.